you want to think of drawing a right triangle, and please put the letters A to F to E. So that's this one on the bottom. So remember in class I showed you that box? That's this triangle on the bottom, from A to F to E. The right angle is at F. The one that we are actually asked to find the answer for goes from A to D to E. Okay? So this is going to be from A to D. This is going to be your final answer that we are looking for. And this is E. And what you notice is on this triangle over here, so if you didn't draw these, make sure you draw them with the letters in. And if you draw yours the same way that I did. So do your two right triangles with the right angle here and the right angle here. And what you notice is that this side AE is the same over here. Right? Going around this triangle, it's going to be the same. This is going to go from A to F to E. And make my right triangle a little more right triangle. A to F to E. This is going to be on the second right triangle. If you are looking at it, it's going to go from A to E to D. Now, again, this side AE is the same here. So when you look at this problem in your homework, and you will have one of these on your test with these triangles, with the squares, we know from A to F, looking up here, is 7. So put in 7. What do we know the length from F to E going back is? Look on your box. What is the length from F to E? 3. So when you start this problem, this is going to be your first length you find, and that is the same length that goes in here. Okay? Do we know the length from E to D? Up here. Careful. On the bottom, it's 5, because A to B is 5, so all of these going up have to be 5. So we are going to start with A squared plus B squared equals C squared. On the homework that I handed back, the most common mistake that I had is people left this as C squared. So they put in 3 squared and 7 squared equals C squared. And they start doing that, and they put 9 plus 49. And 9 plus 49 gives us 58, right? That's our C squared. So what is C? If we're going to keep it exact, it's the square root of 58. So what I saw in a lot of homework that you turned in on that B5 homework is you left your answer like this. And 58 doesn't even make sense. 3, 7, this side is 58. So some of you, this is the square root of 58. Now, why am I not going to put that in my calculator? Because over here, when I plug in square root of 58, right, I'm starting this right triangle with A squared plus B squared equals C squared. If you didn't do this, write it down. And here I'm going to put the square root of 58, and I'm going to square that. Plus 5 squared equals my last side from A to D, which is what I'm trying to find, C squared. When you take square root of 58 and square it, it leaves you with 58. Plus 5 squared is 25 equals C squared. We are going to add these two together. 25 plus 58. If you need to do that on your calculator, please do so. Makes sense, 83, but the square root of 83, and now we're going to approximate that. And that square root of 83 should have came out to be 9.1. So this length, 9.1 in this case, centimeters. Okay? That is the steps that you have to go through when you are asked to find the diagonal in a box. You have to do 2 right triangles. So when you do your homework in the next few days, you have to practice it and be very diligent about how you practice and find these lengths, okay? I can find the distance between 2 points on a coordinate plane and real-world applications. So the real-world applications were like finding the volume, finding the length in a box. So a coordinate plane is formed by the intersection of the horizontal line, this is our horizontal called our x-axis, and the vertical number line, which is our y-axis. The axes meet at the point 0, 0, that's our origin, that's this point right here. And we divide them into quadrants. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And they go kind of counterclockwise if you're looking at those. It says points in a coordinate plane are represented by an ordered pair. The first number is always the x, kind of alphabetical. The second number is the y coordinate. So if I was asking you to plot -2, 1, you would move 2 to the left and then up 1 to -2, 1. You are always starting at the origin. So right below this, if you would please write x comma y. And the x coordinate, you will always start at 0, 0, okay? You will always start at 0, 0. The x coordinate, if it is positive, you will move to the right. If this is a negative number, you will move to the left. Then we have your comma, because then we have your y number. If the y number happens to be positive, you will go up that far. If the y number happens to be negative, you will go down, whatever that number is, okay? I am going to ask you, where are the following points? So we look at A. Starting at the origin, we go 2 to the left, that means -2, and we went down 3. So we are going to put parenthesis, -2, comma, -3. I would like you to try B. First thing I'm always going to do is left to right. And to get to point B, I'm actually moving over 4, and then I'm going up 1. So this point is going to be located at 4, comma, 1. When I go to C, I am not moving left or right. So my first point is 0. I am not moving left or right. And then I'm going up 3. I heard some 3 zeros. I heard 4, 4 instead of 4, 1. So just making sure that those make sense to you, okay? Now I want you to plot on your graph. And someone said when you plot and label these, so it says plot and label. What I mean by the label is you're just going to put the letter D by it. So -3, 2 tells me that I have to start at the origin and go 3 to the right or 3 to the left. 3 to the left. 2 means to go up 2. And I'm going to place the point, and then I'm going to put the letter D. You don't have to write this ordered pair -3, 2. That's how you're going to label it, okay? So I want you to do E, F, G, and H. Please plot those right now on your graph, okay? If I was asking you, Ashley Gabbert, you want to tell us how we get to E? Left? Do I have to go up or down? Nope, just like this. And this is going to be E, okay? So if we're looking, Aaron, to plot point F, starting at the origin, what am I going to do?
Go left and right.
Go, wait. We're on this point F right here. So the ordered pair says 3, -3. So tell me I'm going to go right or left? Right 3. Down 3. Okay? So I'm looking at point F. Olivia, you ready for G? Yep, I want everyone to add G and H. If you didn't write those two down, write those two. So, Olivia, what would we do to get to G? 3 right? Down 5. Okay. Ramon, if I'm going to look at point H.
I go to the left 5 times.
Okay. Down 3. You are going to be asked in your homework tonight to find distance between 2 points. It's going to look like this. I'm going to ask you to find the distance. So please write this. FG. Now that just means how far apart is it from F to G? And they are how many units apart from F to G? 2. That's an easy one, right? They're not going to be that easy in our homework because we're going to try and use the Pythagorean theorem. So what we do, we just count it down to. So now the other one I want you to find the distance of is AH. So A to H. And if it helps, sometimes it's nice to draw a line between those, but you don't have to, right? If I'm finding the distance from A to H, as I look at that, what should I be looking at? How far? 3. 3 units, right? If we knew this was in centimeters, we put 2 centimeters and 3 centimeters. We don't know for sure that it's in centimeters, okay? On the next page, it says how far is it from point A to C? So what we just did, turn to the top page, that next notes, I want you to tell me the distance from A to C, and then I want you to tell me the distance from C to B. Okay, so we have 6 units, so we are going from -3 up to +3, we have 6. Please also write a 6 down here on your paper. We are looking at B to C. For that one, Audrey, what'd you have? 3 units. So put a 3 here. Making sure you are not counting like this as 1, 2, 3, 4. It is 3 units. 1, 2, 3. Now it says, how do you find the distance when the points are lined up horizontally and vertically? What did you do to find these? We just what? Counted what? We just counted the squares or the tick marks, right? We just counted 1, 2, 3, 4, 5, 6. We just counted, maybe we could call them the tick marks. We could have taken 3, which is the point over here, right? And subtracted a -3. If you take 3 and subtract a -3, that's going to be 3 plus 3. That also gave us 6, right? Subtracting our coordinates. What do we mean the coordinates? Oh, this one was located over at 3, right? The x coordinate here is 3. This x coordinate is -3. So that's one way of doing it. But most of us, if it's on a coordinate grid, we're going to count them. I would suggest the counting method for most of you. Next picture down, again, this time we are asked to find the distance from A to B. What I want you to do first is draw those 2. I want you to tell me the length from A to C and B to C. Did they change from the last picture? No. So we still have 3 and 6. But we are now looking at, and you are going to take and draw a nice straight line, as straight as you can. And we are connecting A to B. And it says, well, how do you find the distance if they're not lined up? Like, we want to look at this one diagonally. So we are going to use the Pythagorean theorem. And we are going to start with A squared plus B squared equals C squared. And as I take a look at that, Matt, what am I using for A?
C.
What number would you use for A?
3.
3. So we're going to have 3 squared. We're going to only have plus 6 squared is going to be equal to C squared. So you are going to put 9 plus 36 equals C squared. We are adding. 9 and 36 gives us 45 for C squared. Is my answer 45? Because this is how some of you left your answers in your homework. Is my answer a side of 6, a side of 3, and a side of 45?
No.
Does not make any sense. You have to take the square root. So on your calculator right now, please take the square root of 45. This is the exact answer, but usually I am going to ask you to round it to the nearest decimal point. And so if we are looking at the nearest decimal point, the square root of 45, we would say is 6.7 units. If we knew the unit, we'd put centimeters, but we're just going to leave it as units, okay? So, turn to the next page. Here, look, the last 2 pages. And what it asks you to do first is to plot the points. So, we need to plot. Joe, if we're going to plot -3, 3 from the origin, tell me what should I do? Down 3 Over to the left. Okay, that's okay, but I want you to think this is our number that tells us to go what first. So this is our first one. So we want to go to the left 3 and then down 3 or up 3. See how that's so easy to get mixed up if you tell me to go down first? So this one tells us left, this one tells us to go up. So we are going to put, we're going to call this one A. So -3, 3, we're going to call that one A. We're going to call this one point B. So 0, -5. I need to plot that point. If I am plotting that, Abby, you want to tell me how I'm going to get to 0, -5? Go down 5. And then 1. That's it, right? We're not moving left or right. We're just going down 5, and this is going to be point B. So could you make a right triangle? Do you want to make your triangle going above or below? Doesn't matter to me. Which way? Just tell me how to draw it. Above. So we are going to draw a right triangle, right? Here's my right angle. How far did you go up? We went down 5 and then up 3 more. This is a length of what? 8. We went back, please no more sound effects. We went back 3, which means this is a length of 3. And now we are going to draw our right triangle, and we are trying to find the distance from this point to this point. So draw that line. So now you are starting, and on your paper, okay? I'm sure if we start with the theorem and put a squared plus b squared equals c squared, do you want to tell me what I should put in for my a? How much? 3. So tell me what else I'm going to write. 3 squared. Keep going, will you? Yep. Plus 8 squared. C squared. Sam, once we do that in our calculator, or just from memory, what do you know? 3 squared plus 8 squared.
9 plus 54 equals 6 squared.
Okay. So here's the other thing. I see a lot of you putting 9 plus 64, and over here you'll put equals 73. Don't do that. Put c squared. So now we are going to put 73, but it's equal to c squared. Are you writing that, Aaron? Okay. So once I have that, I am going to find c. The exact answer is c is equal to the square root of 73, which is approximately, we are going to round it to 1 decimal place. What am I ending up with? Rowan, you got it? 8.5. Okay. We're usually going to round to the 10th place, okay, as you look at that. All right. So, this question says which one is longer. They look really close in length, don't they? It's hard to tell which one is longer. So, we are going to make 2 right triangles. I'm going to have you make this one going above, and tell me the 2 side lengths that you get. And we're going to do this one going below, and tell me your 2 side lengths. Okay? So we are going to have to agree with my work. Square root of 53 and square root of 52. Does that look about the same? 16 plus 36 gives us 52. 49 plus 4. So which one happens to be longer? So this is my CD, right? That's using the 7 and 2. This is AB. Which one happens to be longer? Okay, so put in square root of 52. You've got what? We got to go a few decimal places this time. 7.21, what? 211. Let's go at least that far. This one comes out, those of you that kept saying AB, AB, I'm kind of disagreeing. That's why I wasn't agreeing with you. This one comes out to be 7.281. Okay? So which one is longer, 7.28 or 7.21? CD is longer. And the question says by how much. So if we go to 2 numbers behind the decimal point, how much longer is CD than AB? You're gonna take 7.28 minus 7.21. How much longer? Not much, right? 0.07, like it's 7/100ths bigger, okay? How much longer? 7/100ths longer than a B, right? Some of you didn't write this, so I think you'd want to write this. And sometimes as I'm talking, if you write it, then we don't have to wait for you, okay? So I'm going to go to the right 6, I'm not putting a point, and then I'm going up 7. And I'm labeling this with an A. And then I'm going to do the -1/7, and I'm going to label that with B. And I'm always going to draw a line segment. So I'm going to see a bunch of line segments. I should see 3 line segments. And then for questions 4, 5, and 6, I'm going to see 3 triangles. And you have to use Pythagorean theorem if the 2 points are not vertical or horizontal. Okay? Just like we did in our notes. If you turn to the back of this page, these are some of the applying it in a situation, right? That's one of our key standards. Question 11 and 10, I highlighted those ones. You have to do all of this, but you're going to see very similar questions on the test. So I want to look at number 11 before just to alleviate a few questions so that if you're working on this. So number 10, most people do okay finding this. And then it just says that each square here counts for 100 yards. So you got to just multiply your answer at the end by 100. But look at number 10. It says, here is a 7/4, right? So we know this is 7. Can you see how it's 7 by the tick marks going across here by 4? It says this is a 4-sided shaded regular area of the grid. Find the perimeter. What the heck? How do you find perimeter? What does that mean, Danny?
Finding the distance around.
The distance around, what are we trying to find the distance around? The dot paper or the shaded figure?
Shaded area.
I need to go the distance around the shaded. So I am trying to find, please write, distance around the shaded. Can you tell how long this side is right here of this shaded region? Do you have any idea how far that is? What do you think, Audrey? 1 unit. How do I know that? Because over here it's 1 unit, right? So this is 1. So I know when I start my perimeter, I know I have to have 1 plus. Can we tell how long this side is up here? Yeah. How far? 4. How do I know that? Because I can look down here and go 1, 2, 3, 4, right? So this is 1 plus 4. But now I got to find this length right here. What am I going to do to find it? What have our whole unit been on? Right triangles. And this is my C, right? And this is like A and B. Can you tell me the length of A and B? Yeah, and you got to find C. Okay, so I find that C. I'm going to call this C sub 1. How do I find this length over here? I have to find another C, right? Can I tell the lengths of the sides of the right triangle? This is going to be C2. This is going to be my A and my B now. So is this an impossible question? Because this question comes up on the test, and I have people go, what? And in the review, and they struggle with it. So you have to use the Pythagorean theorem twice, just like in last night's homework when you were finding that missing side, okay? So you have this, both pages, so there's 3 pages for B7, okay? 3 pages of B7, okay? If you have questions,